See if more folks are joining. We put in the snack. I've added a couple more people, but I guess they will not show up. I think we're live. I just so let me do the intro and welcome to the office hours. Kubernetes office hours. Today is June 15, and we have a couple of folks. Welcome everyone. We are here to introduce Kubernetes SIG. In a moment, we'll let you know which one it is. Answer your questions live on the air, and it's the with experts that we get and volunteers. So these are volunteers, and check the topic in the URL. Before we start, there are the ground rules. We have a Kubernetes this is a Kubernetes event from Contribute X. We follow the code of conduct. It's in effect. Please be excellent to each other. This is a judgment-free zone. Everyone had to start somewhere, so please help out your buddy by having supportive environment in the channel. The channel is office hours. While we do our best to answer your questions, the panel doesn't have access to your cluster. We cannot do live debugging. We'd love to do that. Maybe we can do it afterwards. Panelists, you're encouraged to expand your answers with your own experience. So a lot of people that we invite and volunteer have actually experience at work with Kubernetes, working in production. Audience, you can help by pasting URLs in the channel. Keep posting questions in discuss.kubernetes.io. The ones that we can discuss was a couple that I found recently that didn't have an answer. So usually that's what I do. You can help out by tweeting. And the panel is made of entire volunteers. So with that, I think we can do a few introductions very quickly. I will go around. So let me add a couple of folks that joined. I think Dennis joined. I think I saw somebody else joining. Archie. So I'll go first. My name is Carlos Santana. I help. I work for IBM as a cloud architect, but in Kubernetes, I'm right now contributing to SIG release. I'm the lead for release notes, and SIG release is being my home for the last few months. So I'm there. So pick me in Slack. So we'll go to the next person, Deems.
Hi, my nickname is Dims. Usually you can find me in places like SIG Architecture, SIG Node, and a few other places. Code Organization is another channel, Slack channel. So I've been doing Kubernetes for a few years now, and it's been a blast. Just meeting people here, and having fun doing things together for sure. So looking forward to the panel today.
Yeah, thank you, Chris.
Hi, I'm Chris Privateer. I'm a software engineer on the developer relations team over at Equinix, and been doing Kubernetes for a while, but latest contributions are in kind of the cluster API provider areas for the Equinix Metal stuff. So excited to help you guys out today, and it's my birthday.
Oh, happy birthday!
And Kubernetes.
And Kubernetes birthday?
Yeah, well, it was just a few days ago.
A few days ago, yeah.
A few days ago, yeah. Good. Happy birthday, Chris. Hi, my name is Yogi. I am a principal solutions engineer at Yugabyte. I'm based in Singapore, and I have been working with Kubernetes for close to 4 years now, I guess. And I have a variety of experience setting up things for customers and partners and all. And mainly, like, my contribution is that I have been doing community work within Singapore and in the region for Kubernetes.
Very good. Arki, you were able to join us. Quick introduction.
Sure. Hi, my name is Archie. I'm custom engineer at Google Cloud these days, and I'm CNCF ambassador based in Montreal, Canada. I'm organizing Kubernetes and CNCF meetups across country and teaching Kubernetes at universities. So happy to be in this amazing panel and see the Dims with us today. It's amazing. So looking forward for the show.
Yeah, it's a great story to listen to someone in university, right? Talking about Kubernetes and this technology already.
I
Um,
know, yeah.
and then we have Dennis. I think he doesn't have a camera, but I think the audio may be working. Dennis, you there?
Yes, I'm here. I am an operator of Kubernetes. I'd say my first time I tried it was 6 years ago, and currently I work on a team that deploys Kubernetes clusters around EKS. So
Very good. Um, so with that, what we're doing with Kubernetes office hours is, in addition to pick up a few questions from discuss, we try to bring someone from every SIG. David Rocco started that, and I continue that as the host. I do it as a selfish reason. That's a way I can network and learn about all these SIGs and which one to join next, because I want to contribute more, and then learning about what they do, because there's many SIGs and I keep learning and meeting people. So KubeCon, I met a lot of people. So for today, we are going to talk about SIGs. I don't know if I pronounce it correct. K8s architecture, Kubernetes infrastructure, the infra part, and we have here. I think Dims, you're the share, one of the shares, and we'll talk with Dims, and Dims would introduce us of um, things like what is the SIG, what do they do, and then see if you will be interested in joining their meetings and then learning what they do, and then become a contributor, a member. Who knows? A few months, you are a lead and a share, or leading one of the efforts in there. Dimis, if you don't have anything to share, I can share the website so people can see where they are as you speak.
Where do I put it, in the private chat, or?
Do you want me to share something, or you can share?
Yeah, I put it in the private chat. Should I put it in the HackMD instead?
Let me see what you have. Yeah, you can share your screen if you want also, or I can share it.
Yeah, please go for it.
Okay, let me share it. 1 second. So we're going to go to the side, and I'm going to share. Let me share my screen. I'll share this one. Yes.
Thank you.
So this is the Kubernetes blog.
Correct. So where did we even start, right? Like, what does this working group do, and why is it a working group? Might be some of the questions that you have in your minds. So the way to think about this is, when Kubernetes got started, there was a lot of infrastructure that was set up on the Google Cloud, including things like the CA jobs that run pre-submit jobs, as well as the periodic jobs that ensure that your PR is green and it doesn't break anything. And so almost all the kinds of things that you need, including downloads of the debs and the RPMs for Kubernetes, downloading the container images, all of this was in Google Cloud, and it was maintained by folks from Google, and they were paying for it as well. So over a period of time, we realized that the community wanted to have a say in how things are run, how things are set up, and Google also wanted to, like, hey, how do we reduce the burden on Google engineers, and actually count how much we are paying for, they are paying for it, and we are using it, etc. So, right. So what ended up doing was, we started a working group to look at these issues and see how we can move certain things out from Google engineers' hands. And the community will then have a say in how things happen. So what we ended up doing was, we went to CNCF and we said, CNCF, we want to do this. We want to make sure that people in the community are able to do things like make a release. For the longest time, Kubernetes release was handled by folks from Google as well. So there was a lot of things that we were not able to do as a community that we wanted to do. So we said, okay, let's create a working group here, and we'll set up some infrastructure. Maybe we'll start on the Google Cloud itself, but the idea would be to go from Google Cloud into Amazon and Azure and other clouds as well over a period of time. So we set up a bunch of infrastructure in the Google Cloud, and then we are slowly moving things out from the existing projects, GCP projects where they are running, into the projects owned by CNCF. As a result, what do we get out of it is we know what applications are running. We make sure that we have the source code for all the applications. We are able to build newer versions of things, and we know what scripts are being used to run. We know that we can replicate the builds for the different applications without having to depend on somebody's desktop deep inside Google, for example, right? And when we have new people coming to the community, they are able to see and touch and feel and make changes to the things that we are trying to do. We are also enabling SIGs to have their own staging repositories for container images and whatever else that they need as well. So if you go through the different items in the blog post, you will see that we have been able to move DNS records. For example, say Cluster API. Cluster API has a documentation website, and there is a DNS for it, and that is managed by the K8s-Infra team. If you go to SIG release, and they are cutting releases on a regular basis, where do they store the images? That is a spot that was created by our team. And most of the stuff that we have are either in bash scripts or Terraform, or a mix of both. Another example would be typically you will see that the day after a release happens, you can start using client Go, for example, right? Where does the publishing bot that creates these tags for different repositories, that's a publishing bot that runs within Kubernetes Infra itself. So what we are trying to do here is, like, we want to do a bunch of things. There's a lot more things. We have done a bunch of things, but there's a lot more things in the pipeline that we need to do. What we are looking for is people who are hands-on, DevOpsy kind of mindset, where they can roll up their sleeves and start writing stuff, where they're able to set infrastructure up, and then we document the things and we tell people how to use it. For example, if you want to create a new bucket in GCR, then you go edit this YAML file, and then you push this button to run essentially the scripts that are going to create the staging repository that was newly added to the YAML file. So we think in those terms, how to make it easy for people to request the things that they need, and how do we provision those things with the least amount of effort from our side. So we need people who are good at doing the DevOps stuff. We want people who are able to think a little bit ahead, as well as so that we can figure out, like, hey, what is the biggest problem today that we have, which is we are running out of money because we have so much infrastructure that we already got from the Google side to our side, that we are hitting our limits. For example, we are spending a lot of money in downloading binaries, in downloading container images. So then we took that as a problem and said, how do we reduce the cost? How do we spread the load to other cloud providers? So we want people who are able to think in those terms, which are forward-looking, and kind of like get to the point where we have solutions ready to scale up, ready to actually scale up to what the whole community wants us to do. It's a lot of interesting problems, and you get into all kinds of corners in different cloud systems. as well, and it is definitely a fun place to be in because you're helping your fellow people and do the things that they would like to do. Hopefully that helps to give an overview of the things that we are trying to do here. If you have any questions, we have a Slack channel. You can hit me up on the Kubernetes Slack or the CNCF Slack. So yeah, there's a mailing list, the whole shebang. We have bi-weekly calls as well, for sure. So if you're interested in this kind of work where you are able to help other people in the Kubernetes community, please come and talk to us. We would love to have you.
So am I muted? I'm not muted. Can you hear me?
Yep.
With these things. So a couple of questions. Do your SIG is like a provider to other SIGs of infrastructure? For example, for people that are not familiar, how we're producing Kubernetes. So when somebody submits a change to the Kube API server, right? They change one line of Go. Hopefully they write a test case as a best practice. We tell them like, where's the test? That's been something that is in the radar lately, right? The quality improvements. But what happens there when a PR gets created? Does Kubernetes gets deployed in GKE? I don't think so. Or a new Kubernetes cluster that gets deployed in VMs, a small one. Like somebody needs to pay for that infrastructure and also the automation of it. So there's a delineation between testing on your SIG testing and your team.
Yeah, there's a lot of overlap between the different SIGs. Like I'll take one example, right? Say you are making a change in Kubernetes repository and you're updating a Go file there. What ends up happening is there is a definition for a number of pre-submit CI jobs that run to give a green signal on it. Now, these CI jobs are launched on what we call Prow, and Prow is running in a GCP cluster, right? Typically, Prow runs inside a GKE node as a pod, and then if it needs to stand up a full Kubernetes, then it gets one GCP project where it can do that work and essentially starts a local copy of Kubernetes. Most of the jobs don't need to do that because all they are doing is like run verify checks on like, hey, is the Go formatting fine, or is something is a spelling check is another example, and there is a bunch of other verify scripts as well. But there are some scripts that actually need a full Kubernetes cluster to actually try the test cases and make sure that the change that you introduce doesn't fail. So essentially what I'm trying to say here is like most of the things are automated. The CI jobs are owned by SIG testing, and the infrastructure they run on is provided by us in the K8s-Infra.
I see. And you're doing automation also so in your realm will be automations to define like as much as possible do infrastructure as code, like declare like you want 3 buckets, we want 3 GCP projects.
Absolutely.
We want this configuration in DNS.
Yes.
So for just trying to explain for people that are like trying to learn that space, or maybe they already have skills in that space, maybe they're the people that are interested in learning more or helping out.
Absolutely. That is definitely a great examples of the automation that we do. Another one, which is probably a little bit more what other people have ended up using, is creating mailing lists and adding people to mailing lists, right? Like, for example, we have automation that creates mailing lists under kubernetes.io. So in fact, earlier we used to have Kubernetes-dev at Google Groups, whatever, right? Now it is dev at kubernetes.io, and that is taken care of by our automation. So that was one of the things that we rolled out, where if any of the SIGs want to create a new mailing list for an ACL, so that they can say, hey, this GCP resource, to view this resource or edit this resource, you need to be in this Google group. So we end up having a YAML file where there are definitions for what the mailing list is, what the name of the mailing list is, what is the comment on the mailing list, who are the maintainers of the mailing list, who are the admins, and who are the members. So all people need to do. A simple example is when the new release team starts up, they go and update the YAML files, and people automatically get access to all the resources that the release team needs to do its job.
Yeah, so very, very heavily infrastructure as code, and note in there in Knative, I'm steering for Knative, so we just joined CNCF, but we've been doing a lot of we took that code, that tooling to create those declarative way of declaring the groups and who belongs to them, so they can have access to this resource in the GCP project or that resource in GCP project. And we brought that into Knative, so there's other projects benefiting from this work. So if you join this SIG, your contributions is not just going to benefit Kubernetes, but it may benefit anyone in the world. In our case, will be another CNCF project like Knative, because we are using this type of automation. So we have a way of like spending our time in other things than trying to edit and configure things in consoles with the mouse and things like that. So for those that want to learn more about it, I put the link in the YouTube stream. But basically, every SIG has this format. They're in the Kubernetes community repo, so you will find in the readme.md, and actually we do automation everywhere. So there's actually a JSON file behind this, or a YAML file, if I remember, that drives this creation of these README files that have consistency. But you can see here when do they meet. They meet Wednesdays at 20 UTC bi-weekly. You can actually see what are they're talking about. Join the Zoom. So as my recommendation, one person that I've learned lately is I've sent people here. I think I sent Mohammed from Kennedy. Yep. He wanted to learn, and it's just like just lurk around, like just join the meeting and listen. Like that's to be your first step if you're joining. Just listen at what they're doing. Maybe they're talking about this mirroring of the images across the cloud providers. Maybe you're interested in the proxy. Maybe you want to look at the code and get interested in there. And then learn and then help out, right? Raise your hand saying, like, I want to shadow someone that is doing that. So that's something that maybe we infuse in other SIGs, like that shadow thing of like being a shadow first, not taking responsibility for something, and then until you feel comfortable. So I know Deem seems to leave. I think he's late to his other meeting, but anything that people want to add, or Deems yourself?
Nothing from me. Thanks a lot for the opportunity to pitch for something which is really close to my heart. Thank you.
Yep, eliminating toil. That's what I call it, right? At the end of the day, and I think a lot of people in our space in DevOps can be familiar with that, and some people that want to get into this space, right? They want to learn. Hey, the best bet to learn is like joining an open source project and learn about this. With real things. These are real infrastructure, real resources, actually cost money. CNCF pays for it. We have to be efficient, right? So minimizing costs and toil are kind of the goals. So if you're in that space, you'll be joining other people with that mindset.
Thanks a lot, everyone.
Yeah, thank you, Deems.
Yeah, bye.
So there you have it. There's maybe there's a question in the chat. I think I saw. Let's see, can someone send a link? Oh yes, that was in the every SIG. We have so many SIGs, so this is community SIG K8s-Infra. Every README will have the recording, so you actually can see what they talk about in the last one, and then the link to the Google Doc, which I can copy into the chat. And these are documents that are free. You don't have to belong to a SIG or have special permissions. These are docs that are like anyone with the link can access. And as you can see, Deems is the share. Our node is another share, and you have the leads here. So reach out in Slack. There's a channel, and also through the meetings. If you can attend, that's good. If you cannot attend because of the time, right? Globally, you can just join the Slack, watch the recording, and then ask what you can help or who you can shadow. So that's that one. Let me hide this one. I added the link. So anyone on the panel learn something today about K8s Infra?
Definitely, I did. I mean, it looks pretty interesting, and especially like Tim's actually defined what kind of people would be great fit for this particular SIG. Yeah, based on my own experience, I would probably give it a try.
Yeah, and I think I try to highlight when there are many SIGs that people can contribute, and you don't have to have 6 years of Go programming and Go profiling, right? That's the perception that people think, that to join Kubernetes SIG you have to have this background of being an expert in Golang, because the majority of controllers and everything is Go. But we have code that configures infrastructure, right? Configuring the plugins for Pro, configuring the GitHub. There's automation for GitHub. He didn't mention that. The automation for the mailing list, the automation for the groups, and a lot of those things is infrastructure as code. Like it could be Terraform, it could be Bash scripting, a lot of Bash scripting. So a hint is, if you want to see a lot of Bash scripting, look for the hack folder. There's usually a hack folder, and there will be a lot of shell scripting in there, which is nothing wrong, right? And we get a lot done with that. But yeah, that's you don't. DNS, also another thing that maybe you're familiar with, a lot of DNS records, how to create them, how to create external DNS. Also is useful for those type of things. So with that, I think we can move to the questions and answer section. So let's move to the any comments before we move. So I think I will have SIG. I'm not promising anything, but I'm trying to get SIG security next month. So that will be a good one. The security is becoming a hot topic lately. So let me bring so we're done with this. This is the blog. People wanted to, let me share this on the.
I've already put the link on the HackMD.
Okay, good. And then I'm posting the blog. And for the HackMD, the HackMD is just for internal purposes for us. But the first question that I found, I don't know if you folks have found any questions, but usually in discuss. So the first question is this one. Let me bring it into. I'm still sharing the main thing in my screen, right? No.
Yeah, we can see the split HackMD.
Yeah. So the first question is question 1 from Medhi Jafarpur. Let me see if that brings the HackMD. I don't know why, but let me see if I can get it from the discuss. I think it's an error with the markdown. So usually what I do is I look in discuss for the latest questions that they don't have an answer. So this one is the first one, which was very, very interesting. Expose node information to a container, asking, coming out. I need to, okay, so it's Kubernetes 120, which I think is using bare metal, but it says, hi, I need to expose node related data like the node names or labels as a variable or inside the container. I read that about the downward API volume file, but it only handles pods data. How can I do that? So he wants to get information about the nodes from, I guess, from inside a container, inside a pod. It could be like a pod that it does infrastructure things. It could be like, say, something for the SRE team, something like that. About the cluster, I'm guessing it's the same cluster that he's running on.
We should bring back Dims to the call. He's gonna give
Yeah.
But I put a few answers actually on this one. Like first, there is actually open issue like feature request around that, which has never been closed. So that's definitely maybe +1 if you're looking for this type of functionality. And that's why it would be nice to have Dims on call so he can actually comment on how we can push this request faster
Do you
forward.
have the issue? I don't see it.
Yeah,
You have it in the private
it's in
chat?
the. Let me put it in the chat, but there's also in the
Slack?
comment of the HackMD. I'm gonna put it here as well. And yeah, like there are some people, what they do is basically they're using an init container that is running kubectl, and you basically can run a command and it is a init container on to get the node labels from your node, and then expose it as an environment variable, and then you can read it on your pod, right? So this is like not a most optimal way, but this is like a kind of a hack that you can do yourself in order to get this information. There is a feature in Kubernetes as well that has been recently added called pod topology spread containers. I put it a link as well. This one probably not gonna solve the problem, but like it's one of the use cases where you wanna potentially apply to your pod specific zones on the cloud. It's like one of the, I guess, use cases. But like for the specific answer that, for the specific question like that they're trying to use on bare metal, I don't know like any other solution than just use kubectl at this moment. I don't know if you guys have any other ideas how this can be achieved.
So downward API will actually give you the node name, so you can actually get it from the pod spec. So you can say spec.node name. You can put it in an environment variable, or you can put it in a file, either of those. And then the second part, which Archie already mentioned, have an init container with kubectl, which will go and query that node's labels and maybe put it in a file or maybe put it on an environment variable. So that's how any node specific information you'll have to query it using kubectl. But the problem that the person might run into is getting the node name where the pod is scheduled. That you can actually get from download API.
So I believe that the downward API, so to summarize, as out of the box, I think maybe comment said that I didn't see that, but I think the first comment was the same thing I was going to say, like, exposing node information metadata to a pod by default, that's a security risk, because that's a leaky abstraction. Like a pod should not know where is it running, in which cloud, in which zone. Like it should be like so it has the flexibility to run on any node, and also not know anything about, the same way the container doesn't know that it's running in a pod, right? It can be running in your computer, it can run in a pod. The same thing for the pod, should be like not aware of where the specifics on it. But there might be reason that you want that information. So like Yogi said, two things that are usually exposed in the pod is the node name, I believe, and also status host IP. So you can actually get the IP address. So those two things are things that you can get. So you know which node you want the information from. So that's the first step. Maybe you don't want the information of all the nodes. You want the more information about the labels of the node that I'm running on. So that will be the first thing to interrogate, and you can get out of the box without permissions. So the next thing is, then you're going to be like, I could say like kubectl and an init container. So either you modify if you have one single container, that container, then it needs to talk to the kube API URL, right? It could be with a library, Node.js, Python, curl, kubectl, and interrogate the kube API server, which is very easy to find, right? It's a service in the default namespace, but you need access. Like how do I get access to like do a get list nodes? Then you'll be modifying the service account permissions. So start by giving like the minimum information that service account needs to get that information. But then I think Arki brought a good idea, which is the init container. So maybe you don't have access to the code. Maybe you don't have access to the container. Maybe the container has a contract that says like, I need these 5 variables, and it's done by another team or another vendor, and I need this information here. I think a good pattern is what Arki said, like creating a unique container that has a BC box or something like a shell script, which is you're starting from scratch. You know, and you are maybe one of the people we're talking about. You're not a programmer. Maybe you're a DevOps person, and using Bash is fine, right? No, we're talking about you don't have to be ashamed of using Bash and use kubectl and run an image on that unique container that boots up. The service account needs access to the Kube API server to have access to interrogate the node labels. Maybe that's the only thing that you need. But take into account that the other container will also have access to that. So that would not impede that second container from getting that information directly or getting more information that it should. So it depends how the RBAC um, permissions are granular enough. If you just need the labels, maybe listing nodes is enough, but not getting the data. But listing also gets the whole data of the node. So be careful listing versus get in RBAC. I've been beaten by that before. Like I give listing thinking that you cannot read the object, but actually listing you can get the whole object. So don't get beaten by that. So you will get like kubectl get node one, all the YAML, you will get all that information the other container does. So yeah, write a bash script in that init container. I think it's a good idea. Get those values with curl or with kubectl, make those variables like environments.ini files and put them in a share folder with empty there, right? And then the next container, first thing it needs to do is like load that file, because you cannot create environment variable for that second container. That's also, if you're maybe not aware, but put a file with like a .env file, and then the second container you can like wrap that bootstrap, like I'm going to load the environment variables and then execute the second process, and then that second process will have the environment variable. So I think that summarizes kind of the ideas we were talking about, right? But you have to be careful, because if you just want to share the labels, that second container will actually read the whole YAML like capacity of that node, right? How much memory it has, all that information about there will not be major secrets, but it might be a security hole. So I didn't know about this link, so I'll construct the answer and post it in Discuss. What's the status of this issue?
It's open.
Still open, yeah.
But like it's a bad thing, not a bad thing. Or exposing, it's difficult because then people will ask like, I want the pod to be exposed to anything in the cluster, right? We have RBAC there, so it's another pod. Just use RBAC service account to get the information that you need. Maybe the pod should not have access, so it's a tricky problem. But I think the pattern that we provide is like, I think the best one that we know about, and you know your trade-offs of giving that service account permissions to get that information. Yeah, you can talk to the cluster group API, and get anything that you want in there. I think we've been
most of the time when I have actually run into this particular question, like how do I get node information, labels, and all that, most of the time this has been for sort of enforcing some sort of NT-affinity kind of practice. So it's like if you brought up a pod on the same host for some cluster of your application and all, it's typically for those kind of use cases that I have seen this question being asked. So that's where I would always say, just reconsider your design. Instead of actually querying the node name, maybe try and use the affinity rules to sort of spread out your pods and all.
Yeah, or like you said, the new thing about the pod topology, spread constraint, which is I think it's newer than the anti-affinity pattern.
I have not seen it. I'm actually seeing it for the first time. It's pretty cool, actually.
Yeah, I don't know what version this got.
124.
124. I think it was before that.
No, it says here, right?
I think it's one.
Oh, min domains. Okay, just no. Min domain.
It's been a while.
Domains.
Yeah. I think in newish. Well, it's just 116 here. So. Oh no, I think this is the old one, the regular node label. But yeah. And if you are I work with OpenShift a lot. OpenShift is downstream. Also look into your vendor. Like it could be that you're not using vanilla Kubernetes, so also look into your downstream or Kubernetes vendor, and they might have a feature that you can leverage. So for example, in OpenShift, you can label the project or the namespace with certain labels, and then that will make every pod land in that namespace kind of thing. For Zone. So good one. I picked that one because it was interesting. Like for us that we have been like work in this, like, yeah, it's in any container, kubectl, like doesn't work. Like you will try and say, oh yeah, it doesn't work. I need to give it permission. And then cluster admin right to the service account. And then you got it working. And then wait. You got it working, but you get cluster admin to the service account.
That's risky.
So maybe someone is watching and you want to write a little blog post with a little example and share it in Discuss, like that will help the person, right? Even more than just writing an approach. How are we doing time? The next one is this one. I think this is, we may not have a different answer. Let me see if it opens up. So this is a person that is running on premise Kubernetes clusters. It has bare metal servers and VMs, and I think he's asking, and he includes HPE Apollo, which I was not familiar. That's HPC. So, but he has Dell servers and VMware, all of them running Linux. And it's the approach of, and they have different sizes, like you can have sizes in terms of CPUs and memory, and storage is another angle. But I think he's asking is like, if I have VMs from different sizes and I have bare metal system with different sizes, should I have one? It's a good idea to have one cluster with all nodes and different properties, or should I create a lot of like small clusters to collect the servers and the VMs that have the same properties, homogeneous, right? Which is I did some Google search and it came up in a lot of blog posts.
I have the most correct answer for this one.
No, it cannot be. It depends.
Exactly. So
we need to give examples of it depends, maybe.
Yeah. So this has actually been there for the longest time, right? You would always have, even if, let's say, all your servers are VMs, right? So you will have different capacity VMs. I think in bare metal, it's more prominent because you might actually start with a set of servers, and then after some hardware obsolescence or upgrades, you might actually get newer servers and all.
Or prices goes down, right? And you can get more memory, CPU. Yeah. Old servers and the new servers.
Yeah. So, I mean, the assumption there is that, okay, your workload is agnostic of all those, hardware. Like, for example, now we might even see some ARM-based, like on cloud we have.
ARM, yeah.
Exactly. So that is one part of it, right? So unless and until you don't have any issues with that part, right? All of them are running x86 architecture, and they're all running Linux. So they could, you can have one big cluster. There's no problem with that, right? You can definitely have it. You can assign labels on different nodes and their topology. And I believe this pod topology spread constraint that Archie actually posted, it might even help in that case, right? You can define certain set of servers as a zone and things like those. It could help in that. But let's say if you're just starting out, and then if your engineers who are building applications and deploying them, and they don't have a whole lot of experience with Kubernetes, I would recommend keeping it simpler and just like keeping them on different clusters rather than having one large giant cluster.
That's a good approach. Chris?
Yeah, I got this question every time from many users and customers and like people who's using Kubernetes. Like, I think it really, as Yogi said, depends where you are in your journey. If you're on the cloud, there's no question. Like I go with the more clusters because control plane is managed. You can just one click away from creating a cluster or running a Terraform, to build your Kubernetes on demand. Like it takes literally less than a minute to create a Kubernetes cluster. So obviously it simplifies everything: security, multi-tenancy. It's simple for everyone to deploy workloads securely on that separated Kubernetes clusters. obviously, if you get to the scale when you have more than 1,000 Kubernetes clusters, then you probably start thinking like, maybe I should either have a way to manage all of this because I need to upgrade them. So once you get to that scale in the cloud, potentially you will be looking into consolidating your workloads. If you're running on-prem, it's a little bit different story, because on-prem, creating a cluster, depending what type of solution you're using, it might take from minutes to hours to I don't know. I don't want to say months, but like it's becoming a little bit more complicated, the process. So people on-prem, they tend to think about, yeah, I want to have less clusters because it takes longer time to provision stuff. So like if it's a bare metal and if it's not automated process, potentially you'll be looking to adding more nodes and having a bigger cluster. And then you really need to understand your teams, how, trust domain between your teams and the applications, right? And if there is sensitive workloads, potentially like SOC 2 compliant workloads, maybe you want to put it in a separate cluster. If it's dev workloads, if it's less, you have trust between your teams, and potentially you just create more namespaces, deploy your code there, and use some Kubernetes features like network policies, or maybe secure it with Istio, with MTLS. So like there's a lot of features that Kubernetes provides you to secure your namespaces from each other. It just brings a little bit of complexity now. Whereas if you have cluster per workload, it's super easy, right? They just create a namespace and deploy application. That's it. So it's your call, like the person who is doing it. I think things are getting better for the VMware because we have cluster API. So with cluster API, you can easily deploy,
vSphere.
vSphere, yeah. But if you're running on bare metal, unless you have some kind of a magical bootstrap process, it's a pretty complex setup.
Is this where I plug Tinkerbell? Being from Equinix, probably. But
Yeah, go ahead, Chris.
yeah, I would look into that if you want to really do bare metal on your own. Having some sort of orchestration platform for your bare metal servers, like a Tinkerbell or a Metal Cubed or something along those lines, might be a thing to look into. But those are all relatively early on projects, so depending on your team size, you may not want to have to invest all that time into learning those and getting them set up. The day two requirements here could be real heavy lifts if you're going to have 7 different clusters with different hardware platforms and worry about upgrading them. That's going to be a different story than if you don't care about upgrading them and could just blow them away. So this gets back to Yogi's, it depends, right? Personally, I would think if you're doing it yourself, and you really don't want to use a cloud, then do what you can to give yourself as much of a cloud as you can. So having VMware on top of everything to make it all uniform would, I think, help you a lot to make it simpler. But if you've got the resources and the people to expand and explore these other options, well, you have lots of options. And unfortunately, you got to pick.
Yeah. Dennis, any insight? See, Dennis, give it a chance.
I think the question is about running heterogeneous versus homogeneous hardware clusters, right?
Yep.
I don't have a lot of experience here. When I ran on bare metal, we ran homogeneous hardware as much as we could, and very specifically, we had different hardware, like in a data centric use case, and we had different cluster management there, like Hadoop, for instance, or Spark. So we didn't have Kubernetes or home-rolled CPM. This is kind of before the Kubernetes days really took off. So we had to deploy our own containers. So it's a little bit easier for us back then to run something that understood the specific needs of that particular class of work data. So it knew how to exploit that particular hardware better. So a generic solution like Kubernetes, if it also understood, that these containers needed to be scheduled in a certain way and exploit the hardware in a certain way, would be the best bet, in my opinion. But there could be more to this question too once you get into it.
Yeah. I agree with all the thoughts. So one piece of advice is, I think Chris pointed out, maybe you want to put VMs on those bare metal servers. Like that would be kind of a good choice. Like, hey, let's not try to, because it depends on your learning journey, right? I don't know if this lab has been around for 20 years and they have this old hardware, or they just bought it, right? And then they have new people. But I think today, having a hypervisor, it could be the VMware ESXi or the open source, it could be the vSphere, or it could be KVM. Put a hypervisor. I think that will give you a lot of benefits in terms of snapshotting, backing up, like managing the VMs versus managing one single operating system and trying to make it one thing. It depends. I think Arki said like the number of servers that you have. If you have, let's say you have 8 servers and you're going to create 2 clusters and you have 3 masters, you end up like each cluster having one node that you don't have HA, right? So consider having like, what is your day two, like Chris was saying, day two operations, high availability. So if you're in a physical, I usually say I grew up in a data center, because that I started in IBM with System X. It's like noise all day. But yeah, your power and cooling, your availability zone. So if you have the servers of this size, like you have to do your server planning, like putting servers that can sustain the capacity of having redundancy. If like you lose power to half of the lab, right, you want to continue working, so the other half of the lab has AC and cooling and power until you recover. So you need to spread those workloads. So if you have 2 clusters, then you don't have enough clusters to spread them. So it's better to have one cluster, to have those more worker nodes, so you have high availability and you don't waste those master nodes because of redundancy. So high availability, using VMs, in and then I think Yogi said like the learning curve, because one thing is like you throw you said like I'm going to create a pod or deployment, and hopefully we are leaving the storage to the side, because stateful sets, right, you're running maybe stateful sets and databases, and you have maybe fiber channel or iSCSI or local storage. That's a different thing of like how you attach that and who can access that storage. But let's say you're running stateless servers, stateless pods or workloads that they can fluctuate, right? They can be deleted in one. You can scale out easily or scale down, like auto scaling. It could be HA on auto scaling. So what I wanted to say was what Yogi said, like when you run these pods and you run Kubernetes by default, usually doesn't come with all the customization. So the scheduler will put the pod like where it fits based on like how much is available. So if it's a big VM or a big worker node, usually all the pods would like go there. Maybe you don't want to go there. So we talk about the pod topology constraints and the anti-affinity and affinity, and then how do you, or even like there's like custom schedulers. You can say like from on weekends, I don't want these nodes in here. Right, you can have custom schedulers that say like based on the load and based on whatever. So but that's a learning curve. So like Yogi said, like start simple. If you're not aware of these ways of like you can tailor, or I would say like you don't have to do fixed scheduling, but you can do train, right? You train where you want things to fluctuate so the pod lands in the right place when something happens. And that's a learning curve. So start simple, and then once you know, like you can play with labels and ability zones, then you can have bigger clusters with everything inside. And there's nothing wrong with having a big cluster, but take into account when you're going to upgrade the whole cluster, do you do it one by one? And then that's where like, oh, we spend a whole month upgrading, but we spend 1 week installing, right? So your trade-off. So I think it depends. And also look into this one specifically to like on-premise. A data center looks like it's a home lab or like a data center that you own in your company. But that same advice, like Argy said, is maybe not applicable when you're in the cloud, because we have things like, I don't know, one example is EKS has Carpenter. It's an open source project. Carpenter can work with AKS, but it can work with other types, even on premise, that you can create node groups from different sizes. So you can actually not even create node groups. You just like based on the demand of the pod, it brings in a node, and that node can be big or can be small. So that's another project is Carpenter. That's something that you can look at on how the workload decides or tells the cluster what is the node to bring in. So it's very different on the cloud than on premise. So I think that's a good one. I don't know if there were comments.
I
Easy.
think we have just time check. We have 4 minutes. Just want to see if we can, cover some other questions.
Yeah, we have one about Argo CD, which I think that's very generic, and then I think this one is a good one, and we can take a few minutes on this one. And I think this one is a maybe misconception on deployment versus stateful sets. It says if there's any benefits of using relational databases on Kubernetes. I'm guessing deploying relational databases in Kubernetes. Understand case allows to implement a relative easily horizontal scaling, deployment rollback, and deployment and rolling deployments. And it says like it doesn't know how a database, relational database do not scale horizontally. Having explicit schema implies no rollback in general cases. Rolling deployments may mean having two versions of the code talk to one version of the schema. Can be problematic in general case. New changes must be compatible with the old schema. Am I missing anything? Am I right? I cannot take advantage of horizontal scaling, deployment rollback deployments in general in Kubernetes. So I think this is maybe a confusing person that that is thinking databases, running databases as deployment. But I wanted to see what other people think, and then highlight like what are stateful sets.
Yeah, maybe I can. Who anybody wants to take?
Oh, go ahead.
Yeah, so I think like this user is in the mark is in the beginning of the journey, right? Obviously, Kubernetes provide interesting capabilities that can be helpful for upgrades and stuff like that. But if you're using Kubernetes deployments, they're not aware about your application and database, right? So deployments are not friendly to deploy stateful applications because they don't have knowledge. So we created stateful sets in Kubernetes that's supposed to simplify a little bit this journey. So it's basically allowing you to map specific volume to the specific stateful like set, right? So like if you're going to scale, it's going to scale with the same volume, and it's going to have some capabilities like scaling 1, 2, 3, 4, like in some sort of sequence, and then scale back in a sequence. So it provides a little bit better awareness for databases. That said, if you're just going to start using, let's say you want to deploy Postgres, and you took stateful set and deployed it with Postgres image, it still doesn't make your solution a great solution for production, because there's some knowledge that databases have, and each database has its own knowledge. And that's why our community worked on the new set of tools and configurations, what we call Kubernetes operators. Right. So Kubernetes operators, they let you insert some knowledge about that specific database, and create some features like backup, restore, upgrade, schema upgrade, stuff like that. So it usually those operators created from that vendor or like the company that is strong in that space. So maybe for the Postgres, you can find Crunchy-based operator, and this company have a knowledge around this type of solutions. So obviously they're the ones contributors to this project. So we have a place where you can basically go. I forgot the name, which is catalog of operators, and
Operator
Hub. Yeah, so you can technically go there and find that operator, let's say for the Postgres, and give it a try. And it has already all these functionalities for the upgrade, scaling, and taking advantage of all the Kubernetes niceness, right? That said, do you want to go into that business and try to figure out how to run databases? If you're running on a cloud provider, I would probably look into whatever cloud you're using solution. So if you're using Google Cloud, you're probably going to use Cloud SQL that easily lets you create a database, right? And then if you're running Amazon, it could be RDS and so forth. I've seen some customers really going to use Kubernetes because they are specialized in that business and they really need maybe some specific features that even cloud provider doesn't provide. So it's very complex question. And we also have a CNCF project called Vitesse that provides you like horizontally scalable MySQL solution. So that could be another approach as well. But yeah, it really depends what is your business requirements. And if you're running on the cloud, I'll probably first start looking into managed services. And then if you have a special edge cases, then I will probably look in Kubernetes operators that provides this capability. And if you're running on-prem, you're probably going to look on operators more than on anything else. So that's my take on it.
Yeah, I agree. Here's one document. I think, like you said, the beginner Marcus, on the beginner of your journey. So this is one resource. If he walks through, if he's maybe already knows deployments and he's thinking about running a container, or he have seen, for better or for worse, like an example. Like there's many examples out there of a deployment.yaml that has a MySQL container, right? And people just run it like Docker Compose, right? And then like it got it working. Like was like, wait a minute, how is that going to work? Like for the real application, right? I cannot have like a Docker Compose or a deployment just specifying the MySQL one. Taking look into the next step would be like understanding stateful sets, which is understanding that type of resource. And it goes through example, it goes through an example of MySQL. So it tells you about the primary or the master one, and then the read replicas, and then how the read replicas, you can scale the read replicas, and so on. And then the next stage is operators. Mostly at this point, there's many capabilities that are in the system of the database that you need an operator. And most of the databases, well-known databases, either they have a paid operator, or open source with support paid, or just open source for the operator. And then if you're going to run a database in your Kubernetes cluster, run an operator. And then lastly, Arki said, like, if you're going to if you're new to Kubernetes, or even if you're new, if you're thinking about running your own database on Kubernetes, stop. Stop.
Thank you.
Have a drink. Call us in Slack. We'll talk on Friday, and please don't. That's the best advice, right? Use a cloud provider. Like, get the pros and cons. Like, if you're running this on a cloud provider, MongoDB, flavor of SQL, different. It could be a key store database. It could be freemium free. Start with that and see, because what you buying is a lot of operation cost, and usually that comes with toil, not money, but toil, which is time and effort and pain of human beings. And that's the most valuable resource that you don't want to get into. So the advice is, if you're going to do it, stop and look for reasons why not to do it, right? And then when you go down the path, and maybe in your organization there's someone that knows very well what they're doing, and say like, no, we have proven that running our database in our Kubernetes clusters makes sense, and we're going to do one more thing. We're going to run it in a separate cluster and treat it as a database as a service. I've been telling some clients like, okay, we're running a different cluster, and have the DBA team, the DB team, provide the database as a service to us, right? And maybe have it in a separate cluster. They can argue that they want to be in the same cluster and then deal with multi-tenancy, but have it a different cluster, have that team deal with running that database. And then the apps team, you need a database, well, then you do an external connection, or a peer connection, or Submariner, or service mesh connection to that database, and hopefully they're in the same VPC or same network. They're close together, that the network really doesn't matter. But yeah, stop and I look for a reason or not to do it. But if you're going to do it, operators exist, and there's paid ones and there's free ones. That summarized. I wanted to insert that that know.
Yeah, I just want to add something actually. I had the same sort of an opinion, right, for databases in Kubernetes. But I actually work for Yugabyte, so full disclosure here. If you're going to run a database in Kubernetes, make sure it's a distributed database.
Yes.
Because otherwise, if you are going to take a traditional database and just try and scale it on Kubernetes, you are just scaling the reads, right? You will create more headache for yourself. If you use a distributed database, it actually leverages the distributedness of Kubernetes. So yeah, I mean, I agree with what Carlos is saying, but if you are going to run a database, make sure it's a distributed database.
Yes. Yeah.
Otherwise, yeah, you will just invite more problems. I've actually responded to the person. The other 2 points that they mentioned, right? I think the challenge is not just Kubernetes specific, it's more of a microservices and the iteration of version specific. So that those challenges, they sort of remain. So that's where you need a release control. So you use tools like Liquidbase or Flyway to do sort of schema management, even SQLize, like if you're in JavaScript and all. So for every sort of language, you have different set of tools that can actually do the schema versioning,
Schema.
so that even when you're rolling it back, they have the forward and the backward capabilities. And you always have to go in TikTok way. So you need to release a version of your application that can work with 2 schema versions, right? Then you migrate the schema, and then you move the application further on. So you have to do it in multiple steps. So I mean, tools like Flyway and Liquidbase, I've used those. They work really well for those use cases actually, and they work even in case of Kubernetes also.
Yeah, Kubernetes or not, right? It's just
Yeah.
dealing
They
with
are very generic
databases.
problems.
Yeah, databases problems and
They are generic
working with the
problems.
different upgrading.
Yeah.
And that's why people resonate, depending on the application, resonate with NoSQL databases and then SQL databases and graph databases, right? Graph are great
Yes.
databases that the people usually don't think about.
So, I mean, the databases which sort of have schema on read kind of mechanism, which can broadly be said NoSQL kind of databases, it's easier when your schema is very fluid, but then you actually pay in terms of the consistency with those. That's the problem.
Yep. So I was showing Operator Hub.
Yeah.
And also, I think there was is it Kubernetes DB, some project that was like collecting all the operators for databases. I may put that in the answer also. Let me see if I can find it. But I think we're out of time.
Oh,
And people
way
watching
out.
us live. Thank you. So we're going to conclude. Any final thoughts before we close out? Appreciate some folks joining today, as always, and joining for an hour on a Wednesday. So Arki, Jogi, and Chris, thank you so much for joining. Deems had to go, but thank you for representing Kate's the SIG for K8s-Infra, and those of you that were joining. I don't know if I did it correctly or not. If this thing was showing up in Twitter, I think I added Twitter into the stream. But our official channel is YouTube. So if you're watching on YouTube, join us next time. If you're watching the recording, watch us. Join us live. If you watch live, thank you for joining and taking out of your day to join us. So hopefully we'll see you next month. Thank you so much. Bye.